triangles, so we're dealing with more than one. ABC and ADC are isosceles. So when you read this far, you realize, oh, A is in common and C is in common. So they share these 2 points that are A and C. And we are going to draw 2 triangles. And we have freedom of assigning just the third point, that is B. Where do we put B? Let's see. AB is congruent to AC, so therefore it's an isosceles triangle, so the length has to be the same, so it has to be somewhere in the middle like this. So these are the same length. Okay, and D, where should D go? AD equals DC, so I say, okay, so it's another isosceles, so I will draw. There we go, and got it. Point D is inside ABC, so I didn't get it. This has to go inside here, so okay, fine. I will put it in. But it is still isosceles, you know. AD is congruent to DC. So that's what we got in this wobbly drawing. Okay, well, you don't get points for drawing the line straight for your test. So ABC is 40 degrees and ADC is 140 degrees. Okay, what is the degree measure of BAD? So in other words, they want to know how big this angle is. How are we going to figure that out? We only know this, you know, vertex angles here. Vertex angles, I don't know what these are called. So what do we do? Well, you got to use the fact that it's an isosceles triangle, right? So the angles are congruent on both sides. 40 degrees taken up by this. So out of 180, 40 was taken up. So the other two have to share 140 degrees together. So each one gets 70. Right? But that's not the angle we are looking for. We want angle BAD, the red part. In other words, we have to get rid of the green part. So how do we get rid of this green angle? Oh, no problem. This is also isosceles triangle. So out of 180, they used up 140, which leaves only 40 behind, and each one will get half of that. So it would be 20. So the entire thing is 70, and this little part is 20. So the parts that they are asking for, the remaining part, would be nothing more than 70 minus 20. So it's 50 degrees. That's how you do this.